Hello, my Algebra 2 students. We are talking about equivalent rates today, which allows us a little more practice with what we did yesterday. So there are several different ways we're saying to express values that are growing exponentially, just meaning they can all be in different formats. But to be able to figure out the percent rate of change, or the R value, we have to get it into a format where we can solve for that. So the format I'm talking about is this guy, the A equals P times 1 either plus or minus R to the T power. So what our goal needs to be is, if we're given an equation in a different form than this, is we want to be able to rearrange it so that we can get either T or X, whatever it might be, by itself in the exponent. And then our strategy will be to set the base equal to the 1 plus or minus R so we can solve for R. Some little details to remember. The p-value, that's just the initial value. That's not going to do too much here. But what you do want to note is that if the base itself, so the 1 plus or minus R, if it is between 0 and 1, then we know that this is going to be a decreasing function. If the base is greater than 1, then we know it's increasing. And every time I refer to the base, I mean this right here. That part is the base here. All right, so let's try this out. So if we look at the first one, it says, does y equals 4 raised to the negative 2x represent growth or decay? And then it's asking, what is the percent rate of whichever one it is? So what I want to start with is, let's just look at the graph, because the graph alone can answer that question. So into my y equals, let's type in 4 and then raise it to the negative 2x power. I'm going to zoom 6 just to reset my window. And there we go. So just from looking at it, and I'm going to sketch it right here, reading the graph from left to right, I can see this is a decreasing function. Which is not initially what it looks like, because right here, the base at the moment is a 4. 4 is greater than 1, so it looks like it's going to be increasing, but the difference is that the exponent isn't just x all by itself. So that's what I mean by get just t or x by itself in the exponent. So how we do that is we're going to rewrite the equation. So that it's just whatever that initial amount is times the base raised to the x power. So how we're going to do this is we're actually going to kind of take the equation apart. So let's write it down. We have 4 raised to the negative 2x, just like this. What we are going to take advantage of is the fact that we know if you have a power raised to a power, it means that you multiply the exponents. And so when I have the exponents negative 2 and x multiplied together, I can break them back up into a power raised to a power. So I can make this 4 to the negative second raised to the x power, just like that. Because this raised to that power would be equivalent to 4 raised to the negative 2x. All right, now what I want to do, let's clean up the inside here. If I take 4 and raise it to the negative 2 power, that gives me 0.0625. Raised to the x. So now it's in the format. The p-value, that would have just been 1. The b value is now this guy raised to just plain old x by itself. So that was step 1. Now step 2 says take whatever's inside the parentheses, the base there, and set it equal to either 1 plus r or 1 minus r, depending on the context. We already figured out this is decreasing. So this inside piece right here has to be 1 minus r. And now I'm going to solve that for r. So subtract 1. So on my calculator, subtract 1 from this guy. That's going to leave me with negative 0.9375. And then I'm just going to divide by negative 1, which we know is just going to flip the sign. So the r value comes out 0.9375 right there. And so when the question says, what is the percent rate of, well, let me finish that thought, of decay, right? The answer is now this right here multiplied by 100. So it would be 93.75% rate of decay. So we can answer the question once we get it into a format that we recognize. Let's try it one more time and make sure that it's clicking for you. So this next one down here at the bottom says find the percent change to the nearest percent. Same type of thing. So when we're looking at this, don't let the f of x throw you. F of x is the same thing as y, so you could always replace that with y. So 2, and then times 1 minus just 0.3. It's adding an extra 0 there. So 0.3 raised to the negative x power. So I need to get this into the format of p times whatever the base is raised to the t, or in this case, let's make it an x to match. All right. The 2 is kind of negligible. Just leave that out there. This 1 minus 0.3, I'm going to split this up. I'm going to make it negative 1 and then times the x power. So I'm working that power raised to a power backwards. All right, let's go to the calculator with this part. So into my calculator, parentheses, 1 minus 0.3, raise that to the negative 1 power. And I come out with 1.428 and change. All right, so what that gives me, the 2 is still hanging out front, 1.428 raised to the x power. So this is now the p value. This is the b value. This is my x. All right, and in this case, that number is bigger than 1. So I know what that base is really 1 plus r. So I can set 1.428 and change equal to 1 plus r, and now solve for r. So subtract 1 from both sides. I get 0.428 and change. But remember, that's a decimal. Multiply it by 100. So if I subtract 1 and then times 100, that's going to give me 42.8. Actually 42.9%, but it says find the percent change to the nearest percent. So 43% increase. All right. We have a few more to take a look at. Flip it on over. This one here says the amount of cobalt left after T years can be modeled given this. So you're given this big old equation. The amount of cobalt is decreasing by what rate? All right, so we know it's going to be decreasing, which means that base value is going to be between 0 and 1. And so let's work on rewriting this. So n of t equals n sub 0 times 1/2 raised to the t over 5.27. So if you take a look, that n sub 0, like that's the initial value. It doesn't even matter. All we care about is this piece here. So this one's a little different than the last one. To rewrite it, I'm going to have the 1/2, and then I have to separate this exponent so that the t is all by itself over here. So since it's t divided by 5.27, I need that 5.27 to stay in the denominator. So when I split it up, I'm going to make it 1 over 5.27. And then the rest of it I can carry on down. I'm not super concerned with that. This is the piece right here that I'm now going to the calculator with. All right. 1/2 and raise that to the 1/5.27, that comes out to be 0.8767 and so on. So it's really equivalent to 0.8767 raised to the t power. All right, now that I have it in that initial value times 1 plus or minus r to the t power, the fact that it's less than 1, this is clearly 1 minus r. So let's set those equal. So if 1 minus r is equal to 0.8767 and change, subtract 1. So let's let the calculator do the work here. If we subtract 1 from that, that gives me negative 0.1232. And then, of course, just divide it by negative 1. So the rate comes out to be 0.1232, but then we multiply it by 100. And so the R value would now be 12.32 and change. So to the nearest percent, about a 12% decrease. All right. So we've seen 3 of them. That's hopefully enough to make you feel like we're getting the idea. We will save number 4 for a little recap for class. And that's it.